why are we talking about data persistence in NuNet? It is because uh, a big part of computation is data, and it is not about just bringing the data to computation. We also have to make it persistent because we we may have to use later. So the data that we use in a job, in a container, when running in compute providers, we may need after. So that's why we are researching about data persistence. So first, I will give an overview about IPFS, and later I will ask some questions to understand more about our case. So IPFS is a distributed in public data storage protocol. And the main thing here, different from the HTTP, is that they use content addressing manner to consume content instead of location addressing. HTTP uses location addressing, so to consume a content, you have to input the location where the content is. Like here we have the DNS, which maps to the IP of where the content is, and on IPFS, you input the content identifier, which we will talk later about, but it is the content itself basically. So you input the content and you get it from any source. So from any node that has the content, you will get from them. So the main features of IPFS first is the immutability. Since we get the contents from the content itself, we have the content identifier, which is the CID, and the CID is made by the checksum of the content itself, which makes the content and the CID self-certifying, because when you are getting the content, you know that there is no chance of anyone changing the content because the seed is unique. It is the checksum of the content. So yeah, that is one of the main features of IPFS, and it is also not a problem, but uh, it is hard to make updates to content because since the CID is the checksum of the content itself, when you change something, when you update the data, a new seed is generated. So yes, a new seed is generated, which can be a problem. And another important thing is the availability, how the things works on the IPFS, how people share the data. So it is a peer-to-peer network. So each node can retrieve contents from the network and they can ping the contents. So for the content to be available on the network, at least one node has to be hosting. So we will talk about later, but to make it data persistence on the IPFS, we have to manage to have always nodes uh, pinning it. So about privacy too is that, as I said before, IPFS is a public network, so no content is private here. So there's no built-in privacy. If you want your content to be private, you have to encrypt it for yourself, but still your content encrypted will be available on the network. So there is no built-in privacy.
Can I ask?
Yes.
So two things regarding. So we can use any encryption as needed, or is it anyhow constrained by IPFS protocol?
You can add if you want.
Well, that's logical. The next thing is there any way on IPFS network to browse all the CIDs there, or it's just whatever people share? It's not browsable at all.
Mm, I, I maybe there is a way that people did to browse CIDs, but in the internal structure of IPFS and the libp2p, we have a distributed hash table where all CIDs are there and the IPs they have this content. So in your node, in your own node, you have a piece of this distributed hash table, and you can see all the CIDs available on your part. But I am not sure if you can search for all CIDs possible.
Understood, but basically it's still exposed, the
Yes,
CIDs.
it is exposed all CIDs. But when you are a node on IPFS and you consume a content, you don't necessarily have to make it available to the network to put on the distributed hash table. So if you have a content that you retrieve it from a specific node and it is in your machine now, if the other node don't host it anymore and you don't also host it, the content is not available and visible on the distributed hash table. So you can make ways to not be available.
Okay, so which means that we can build our some kind of VPN of nodes or whatever private nodes where we will pin the content to those nodes only, and then they will not be available for anybody else.
Yes.
To the host.
Yes.
Understood.
But important thing, the what will not be available is the map of CID and the IPs. But suppose that people try to randomly access CIDs. So your file still is available if someone has the CID.
No, so I imagine that if we do this, if we kind of select this kind of thing, we will encrypt for sure private information. Now then
Yes.
the question is that it's not searchable, which means we have the so of course randomly you can do, but random string is random string, and
Yes,
then
yes,
we have
yes.
everything encrypted, and then the question is what are the encryption, how to encrypt future proof future proof encryption, which I know
Yes.
that there are people working on that, but yeah, okay.
Yes. So I will talk about more availability. How can we make our data persistence on the network? Because as I said before, we have to have at least one node hosting the content. So one of the main options is Filecoin, but Filecoin doesn't necessarily share the same network of IPFS, but Filecoin uses most of the intern structure of IPFS, like IPLG, libp2p, but it is not the same network. But the majority of APIs and frameworks, when you add some content to the Filecoin, it goes to IPFS too. So this is just a note. And Filecoin is a economic layer for IPFS. It is blockchain based. So you have deals where you have data providers or storage providers. They will store for money. That's basically, and the deals are based on time. There are redundancy of your data. Not on it will not only one node that will store, and yeah, and that let me show an image here about availability that I forgot. That it is this one, which is how can we make our content available on the network? So at least one node has to be sharing. So we have the option to we host our content on ourselves. We have the option to make a network of our own nodes, and we can talk more about later because we could do it with our compute providers, hosting IPFS nodes with compute providers. Maybe this is an option. And we have pinning services too, and pinning services like our companies who will host IPFS nodes and content. The problem with pinning service is that it is a somewhat centralized option because it is a company, and sometimes uh, these companies, these pinning services, they rely on centralized solutions like AWS to host their PFAS nodes. So I don't think it is a great solution at all. And yeah,
I have a question about that if you finished.
yeah, go ahead.
So I'm going to. So the question about pinning is how does pinning work from the perspective, because I think pinning is somewhere is a functionality of IPFS itself. It doesn't need
Yes.
centralized service. So how does that work if you do not go through any centralized service? How do you pin content to a node?
But do you want to know how the inner structure of pinning works, or how?
Yes. Basically, not
Okay,
inner structure, but how do. So, for example, we do not go through the centralized service at all, but we want to do on NuNet ability to pin to certain servers or whatever, certain, let's say, authorized nodes. How do we
okay,
do this without centralized pinning service?
okay. So first of all, as I said before, when you add some content or retrieve the content from IPFS, you are not necessarily pinning. It is optional, but when you pin it, it is available on the network. So, um, to, I think actually I think it is that simple in this case, because if we run our own network of nodes, all content that passes to us, we can simply pinning. There's no secret to it.
Yeah, but that's what I think. So how do we pin without centralized service? I'm sure it's possible, but I'm not even understand why you need centralized service for pinning.
Yeah, I don't know why they use it. I think it is because it is easier,
It's kind of
but
user interface. That's it.
yeah, maybe, but yeah, but we have to ping our content to be available because uh, imagine that we have our own network of compute providers hosting IPFS nodes, and we have a node A who wants to access the content of node B. Node A can only access the contents of node B, or we pass the CID to node A, or if the content is available on the distributed hash table. So node B has to be pinning the content. So the IPFS demo, which is this CLI, has to be running in the computer of the nodes, and has to be pinning the content.
How heavy it is, by the way? Did you check? What's the
Uh,
footprint, memory footprint?
Sorry,
How heavy is IPFS node?
how heavy?
Yes, in terms of yeah, footprint, memory, whatever. How big is
I
it?
don't know. I don't know, but I think it is. I think it is light, not too heavy.
Yeah, well, okay,
Okay,
understand.
so yeah, so as I said, pinning servers are not a good option because they are somewhat centralized, and I think this about popularity is not our case. And about these four options, I think this is only one that it is suitable for us. We can discuss later, which is running IPFS nodes on compute providers, NuNet compute providers. So let me come back here. And so I was talking about these options, and in my opinion, I think that Filecoin is suitable for immutable content because I don't know how easy, and it seems not to be because Filecoin's deals are timeful, so they are dependent on time, and I don't know if it is suitable to use Filecoin to be updating data anytime you want. So I think Filecoin is useful for immutable content like output from jobs and metadata from compute providers that we share only one time. So, and I think that another option, which is running FFS nodes with compute providers, I think this would be a suitable idea for mutable content when we have some piece of data, imagine the CPO case of Cardano, when we are downloading the blockchain data and we want to make checkpoints of in the case the node goes offline, we want to make checkpoints of where the node the compute provider stopped. So in the middle of the job running, he is downloading, I don't know, 10 gigabytes, and we want to store that on IPFS and to later be used and continue the job. So this would be suitable just on this option, not on Filecoin, because Filecoin uses timeful deals, which I don't think it is a good option for updates. And as I say, PIN service are I don't think it is a good option. But I have to say that there are some companies of PIN services that don't rely on centralized companies. I think File uh, Firebase, it is a company of PIN services that they use Web3 technologies to host content, to host IPFS nodes. So yeah, about pinning, and this is something that we have to decide when we want to make our content persistent on the network of IPFS. And yeah,
Okay, just one question regarding Filecoin. You said it's time, how do you time bound? Can you
yes,
explain that?
yeah. So most of the blockchains of storage, there is the storage provider, and you will uh, send a piece of data to be stored to a node, and this node will store for a limited time. This limited time will be based on the beginning of the deal. So uh, it is limited. I don't know why it is limited. Maybe there are another solutions, but most of the blockchain solutions for storage are timeful, have timeful deal. Everything is based on times. Like I have this piece of data and I want you, Node.js, to store my piece of data. How much? Maybe you have to input the time. Do you want this piece of data to be stored for how long? 10 days, 1 month, 1 year.
Basically,
Okay.
with Filecoin, then if I want to store data, I have to say for how long I want to store it.
Yes, exactly.
And IPFS is basically immutable, so the data will be forever unless there is no nodes which propagate it, which then it just dies out.
Yes,
Okay.
yes. So but as I said, most of frameworks and APIs which supports Filecoin, usually when you add some data to Filecoin, it adds at the same time to IPFS. So it will be on the both networks most of the times. So continue. We have another possible problem, which is this nature of IPFS of being immutable, because since the content is immutable, when we want to make updates, we want to change something in the data, a new CID will be generated. So we will have to share this new CID with the users of the data. So this is a problem, because we cannot simply make changes and hope that other nodes are are can access the same CID and get the latest changes, because a new CID was generated. So there are some options that try on IPFS that tries to solve the immutability problem. Actually is not a problem, it's just the nature of the network. But IPNS is the main one, but not the only one. But it is not perfect also. But IPNS is a namespace system based on key pair cryptography, and it tries to bring immutability to IPFS. There are other options like DNS link, which you have to change the records of DNS. And there is also mutable file system, but all of them have some problems that I detailed in the issue if you want to later, because I don't think we have to worry much about versioning and updates of content now, because I think we have some use cases to integrate IPFS which doesn't need updates of content. I will talk later
Um,
more.
well,
Yes,
maybe. So I think, yeah, I see there was a discussion on Discord that you posted, and I kind of more or less understood, but more or less, my question was, can you get, I think my question was more, can you get a permanent address of the Merkle tree itself, of like root node of the Merkle tree, through which you can access, and the Merkle tree in this case would be very simple. It will be just a Merkle kind of line to an extent. It won't be a tree. It will be only two like sequence of writings. So if you have a root node, you can access the leaf node, the least leaf node, the latest, sorry, not least. But what I understood from the answer, that's kind of not possible for some reason.
yes. From what I understand is that, so IPLG, the data layer of IPFS, which is basically the structure of data that brings this complexity, is basically data, which is the piece of data, and links. The case of links is that generally the data has a limit, like 1 MB, and so when you store the data on IPFS, there will not be just one node. There will be the root node and chunks of the piece of this data. So, and the links will take care of these chunks, linking to the rest of the data. So, we, what I think you are saying in the issue is that we have some piece of data that it is the version 1.0, and when we have a new version, we just link the new version of the same CIG. Is that right?
Yes.
So I thought about this in the beginning, but it seems that the CIG, which is the content identifier of each content, is not only made by the data itself, but by the links structure. So as I just I asked it on the Discord to be sure about that, and the the moderator confirmed to me that it is like that, and it is not possible to do this arbitrary updates on the links of IPLG?
Yeah, well, I'm still not sure how this IPLD then works in general, but let's sort of not go deep into that. How much time do we have left?
20 minutes.
20 minutes.
20 minutes.
So what do you think, Janina? Do we go to Bacalhau, which is compute, or do we discuss actually the data persistence?
I can go, yes, I can go through the questions that it is more persistent through the NuNet case.
Yeah, let's maybe I would suggest to discuss data persistence, and at best what we could do, we can maybe draft the architecture the way we move it forward.
Yes, I agree.
Okay.
Okay, so as you can see, IPFast is too general. So since the beginning, I had some questions because when deciding which tools to use, maybe first you have to know what exactly you will do. So I would like to know what are our use case for data storage, because we may have several ones. Like we want to make use of IPFS to as data providers of NuNet. We want to store things of compute providers like outputs, metadata, and we also want to store things of SPOKs of the Cardano node.
All right. So let me can I share the screen? I will just try to summarize the kind of why I would doing all this stuff.
Okay.
And which can be a little bit broader than data persistence. I mean, broader than data persistence, but in general. So right. So we have the whole what we call this kind of research related to data. So with IPFS, there were more or less four kind of goals, excluding the libp2p integration, which let's say another part. So one is data persistence. Data persistence is what you explained, is that we need to keep the compute state, some kind of caching of compute state in order for the networks, for the compute state to be, I mean, not to lose compute state for especially long running jobs when the machines go down in the decentralized network or somehow disconnect. So that's one. And this is, I believe, the main, one of the mains that we have to solve. However, the related thing is data storage, which is we want to store data in order for this data to be accessed by algorithms, whether, let's say, machine learning algorithms want to input data to them, or we want to store data for access to another algorithm. So let's say as an output of the result of certain the process, we may want to store this data somewhere. So we don't need to have single solutions for all of these. However, the preferable way to use at least the same technology and to see how these technologies interact, and also to see to put things that we need in short term and things that we will need in order for the platform to develop in the long term. Now, so regarding Bacalhau or the compute over data things, we will skip for now and we will see next time. However, this is also somehow related. And then the third one would be NFT portal, or the airdrop portal that we are designing, which is specific use case, internal use for airdrop, allowing airdrop to be done as we structured basically. And for that, we were thinking to build data structures where we could log activity of certain people within the network, if they choose to go with it, into the certain data structures that will be related or related to NFTs. And for that, we were thinking, basically, we need to build storage solution, and that may require mutable storage solution where these data structures could be accessed by several, or at least two actors. That is a kind of a context. I think the best if we now start with the first one, based on your research, and then we will see. I mean, we can touch also the second one and the third one. Let's sort of keep for later. The third and the fourth, right? So, data persistence. Okay, so that was the context. Did I answer anything, or it's not enough to answer your question?
Yeah, but you will go deeper on the two first points, right?
Yes.
Oh, okay. So, okay.
So, well, the way I would go, I would kind of try to draw how do we do data persistence, like a start architecture, and then discuss it based on that, if that's okay for you. So it will be slight kind of small brainstorming, but so let's say data persistence. So first, I agree with this, what you said. Let's say to take as a default option plain IPFS. However, now regarding mutability, so the way I was imagining, because data persistence means that okay, we have a container running. Let's say container is encrypted in, doesn't matter. It could be we are running Docker containers and firecracker virtual machines and stuff inside. So if I imagine, so okay, let's say containers which are running somewhere. Now, when they're running, they will change their state. Okay, let's do one container. So before the deployment, I will have just a container which is a bunch of data simply, which is initial state. And when the computation works, we have like different states which change just what is a container. And what you said, checkpoints or snapshots are these interim states. So now, since we have initial state, and if we can calculate deltas here, and if we can write those deltas somewhere, we don't exactly need to store the whole container, which can be huge. I mean, the whole this data all the time, the whole snapshot or whatever. So I was thinking whether we can, yeah, okay, let's say, and then when this machine which is running, because snapshots are stored somewhere else, external, that's the whole point, IPFS or whatever. And then let's say this is compute provider. And then when supposedly an event happens, when this compute provider goes, or this machine goes somehow down and accessible, which will be checked by the health check. At a certain point, we decide, okay, that doesn't work. We have to redeploy everything and to continue the job. So that would mean that we can access all these three with initial container and the deltas, and we can start to run the container from here, right?
Yes.
By putting it on another machine number 2. And that would give us data persistence within the network.
Yeah.
So it seems to me that what we have to build this kind of structure, which is pretty much, whatever you call it, a tree or linked list, basically, something like that. And having that, if we can read all of this structure, then we can simply reconstruct this container and run. And of course, there is an overhead, how much will it cost for us, but that's sort of another question, more related. So this is the general architecture that I was thinking about data persistence.
Okay.
Yeah. Now, how does it fit into what you found? and how it doesn't fit?
It is complicated because, as I said, mutability on IPFS is not simple. So, but yes,
but here, João, we will not be changing the content. We will be creating new content with the delta, with the difference between the stages. We will be adding more content.
Yes, but we would need all the checkpoints, right? Or not? Or we would want just the latest?
Well,
no, we need everything.
Okay.
That is something that I do not know enough, but can we actually contain the delta? Free should contain all the deltas so that you can reconcile. I mean, it depends what gives us less overhead. To calculate the delta from the initial container or to calculate the delta from the former delta.
Mm-hmm.
Like if, for example, we calculate the set delta from the initial container, then we need only initial container and the set delta in order to reconstruct the whole state. Otherwise, we have to read all of them.
Okay, just the initial and the
last.
Where they know. Okay.
Suppose. Depends on how we build it.
Yes.
So we can see strategies of backup. This seems too similar to backup strategies when we have delta variation and, for instance, 1 week or 1 month, a new backup with all the data. We can use hybrid solutions.
Yes.
Yeah. So now what mine was regarding IPLN, since IP, is it IPLN, right?
IPLG.
IPLG, sorry.
Yes.
Now, so IPLD. So suppose we're using that, and what I understood that it actually allows us to build this data structure. So because the only, and the question is this, we can, so what we need in order for this, we need to, all these will be CIDs.
Yes, each one of them.
Yeah, CIDs. So what we need in order to have this data structure is just a link between CIDs. That's it, nothing else. Now we can store this in the IPLD or whatever protocol is available, or we can actually store it ourselves, which is less good because we don't want to be centralized. But basically that's possible. And then when we have this data structure, we can sort of, as I said, we can infer what is the last snapshot, like last state.
So, yeah, I am just not sure if you can link the structures one by one. I think you can do the links just one time. Like you add all the snapshots together, linked from the initial to the latest. But you can because of the problem that we were talking on the issue yesterday.
But, yeah, I understood. But then, I mean, I would double. So how are you going to do versioning, Git type versioning on IPLD then? Because in that case, it's just not possible.
So you can since you are adding things just on your node just now, just temporarily, to when needed other node will get this ID. So I think you can use one of the versioning types that IPFS has, like IPNS and MFS, because you will do all these additions of CIDs, and in the end you just add the latest CID to the network.
Okay, I think I understood.
Yes, and the nodes that get the CID, the other nodes will have all the snapshots. So you do all these additions only on your node, and in the end, you add to the network with all the snapshots together.
So basically, we can traverse the tree from the leaf node, but not from the root node. And since leaf node address CIDs changes all the time, every time you add it, there is no way to refer to the whole tree with this permanent SID. Would that be correct?
Actually, you can access all the leaves too, but when if you want the other node to get access to the latest change, it is better to provide the root, because at the same time that he has the roots, he will have the links to the previous versions, the snapshot 2, the snapshot 1.
Well, let's say so.
If you yeah.
Well,
I was just saying that if you send just the seed one, the snapshot one, he will not have access to the snapshot 3.
So okay, let me draw what I understand, and let me know, because it would be good to know what is this data structure, how does it look, let's say, in whatever the JSON. But suppose what I imagine. So we have, let's say this is CID1, CID2, CID3, CID4. And so I have CID1, I would imagine. So there is a link to initial container. So initial, which is kind of downloadable, etc. And then, so there are two options. Either we have second is the link to the next one. However, we cannot put this because that, I mean, as if we do not know what is the next CD, we cannot put it there, because when it put it there, this one changes.
Exactly.
So then this, we cannot do this. However, what we can do, we can build the next one, and that one, CD2, will contain first address of CD1, and then whatever is the delta data structure that we need. And in this way, we build linked data, right? The problem is here that if I have root, this is root node, I do not know what is the next. However, I can access the higher node from the next node. So which means exactly what it means. Which was I said, we will never know what is last node. Now, what we basically want, if we want permanent address, we want access to here, so that everybody could track down. Or then we have to kind of make a data structure inside our own, let's say DHT or whatever, where we can do the permanent address, where we can ourselves change the CID, the sort of update the, let's say, the DHT somewhere, where we would track what is the last snapshot. And then allow people who, when we will want to reconstruct this container, we will somehow share this last ID, but we will have to, externally from my PLD or purpose, we'll have to keep this structure ourselves.
Yes.
Which is an option. I don't see why we wouldn't do that or wouldn't need. Yeah, anyway, we have data structures in the DHT. And then I believe we can simply do it. I mean, whether we use IPLD or whether we use IPFS, our building this kind of structure ourselves, it doesn't really matter. So then, yeah.
No, just so that a little detail. I thought the opposite, actually. I thought that the CID4, the third snapshot, would be the root node, because I don't see. So the last snapshot would be the root node, because I don't see how you can link the CID2 to the CID1 from the CID1.
Yeah, you're right. In terms of data structures, that's the reverse. But I was just, in terms of time, it's like this one will be first, this is one the second, this is third. Therefore,
for sure.
yes. Right, so it's kind of reversed.
Yes.
Okay, so which means we have to build some sort of pointer to the last snapshot of this, whatever we call it, and we have to put unique identifier there, and we have to keep it permanent until this compute process is finished. And when it's finished, we can just scrap it because we don't need snapshots for like finished compute process.
Yes. So
okay.
There is another problem that I didn't talk before. It is about how will we have to store the information about each snapshot. Like you have all the CIDs that were generated through the snapshots of a container. How we will identify these snapshots? We have the CIDs randomly, but
so
yes, go ahead.
What do you mean by identify?
Like so we have 3 snapshots. These 3 snapshots are from the job 1 to 3, from the compute provider ID, KM, I don't know. So we have snapshots from a container job that comes from, and then the identity, the comes from a specific job. This specific job comes from a compute provider, because if you don't identify, you just have CIDs, you just have snapshots. But we have a lot of container jobs happening in NuNet.
Yeah, so for that we have to, let's say, we'll have to kind of figure out what is this data structure, because we can put either, for one thing, I think CID is kind of a very clever data structure where you can input metadata into CID itself.
Yes.
That's one.
Yes.
Another thing is that we can put it in this payload somewhere in the information. That's some kind of method. Because what it does, so suppose every time we deploy something as a job, we have to also give unique number to the job, not just so, and that will have unique number to the algorithms, unique number to every machine, and then unique number to each job. So, and then we will track this, let's say we will somehow construct the CID so that we will know unique number of the job. And since we will know that if the job is not finished, or let's say it was interrupted somewhere here, we have to reconstruct that job. And that will be somehow, we will need to relate the job number, unique sort of identifier of a job, to the CID, or maybe to have some kind of clever algorithm to figure it out. And then when we see that certain job is interrupted, or certain machine which is running that job is interrupted or is not responding without returning the job, then we find this data structure by that unique number, and we start reconstructing process. I mean, that's very, general principle. This is what I'm saying.
Yes.
Which means we will have to identify each job. And probably keep it in DHT somewhere. So, okay, does that make sense? In general,
yes.
Okay. Sorry, but we are out of time on this technical discussion today. I want to thank you, João, and Kabir, and everyone who is attending. It was a good discussion, and probably we will need to schedule another one to continue on the topic.
Yes.
Okay.
Thank you.
Thank you,
Thank you, everyone. See you. Bye.
Bye.
Thanks.
See you.